In this video, I'm going to go through this pretty fast to look at this stoichiometry review. But for those of you that need a little extra review on how to deal with this is good. So what we're going to do, I'm going to go ahead and take a look at it's 50 grams of CH4. And the question is how much water will I produce? So I'll put water over here, H2O, and 50 grams of this stuff over here. Now the first thing you want to do is change to moles. So the molar mass of this is 16.05, 1 mole, and CH4. So pardon me if I don't label everything as well. So then from this step, now this is always the first step, that change to mole thing. But the second step is always moles to moles. Look at your balance equation, and according to my balance equation, for every 1 CH4, I'm going to produce 2 H2Os. I'm going to put that ratio right there, and that's always my second step. My third step is whatever units you're trying to get to. In this case, I want to get to grams, so I'm going to use molar mass of water. So that's 18.02 and 1 mole of water down here. And that's going to equal 112.3 grams. So that's how much water I'd produce. I had 50 grams of methane, and I just burned it with as much oxygen as I needed. The second problem is a little more complex. It has to do with limiting reactants. So with limiting reactants, one way of doing it is just setting up 2 stoichiometry problems. So what I'm going to do is I'm going to go ahead and say, well, I have 50 grams of this stuff, and I'm going to go ahead and say, well, I want to find water. And you know what? I've already done that problem, right? So I know that this problem is 112.3 grams. In other words, if my methane is indeed my limiting reactant, then I should get 112.3 grams of water. Now, let's take a look at the other thing. The other one is 100 grams of oxygen. So 100 grams of oxygen. So this one, I'm going to do the same thing. I'm going to change to moles. A mole of O2 is 32 grams of O. Oops, make that all together. And then I'm going to go ahead and say, well, in this ratio, if I look at the balance equation, which is my step 2 all the time, there's a 2 to 1 ratio. Well, I'm sorry, a 2 to 2 ratio of oxygen to water. So again, I'm looking for water. I'm always looking for the same product to compare these two. So I'm going to put 2 O2 and 2 H2O. Now, yeah, you could put 1 to 1, but I'm always going to use the actual numbers for the balance equation. And then the last problem, the last step is always the same. And this one, I'm looking for water, and what I'll get in this case is 56.31. Okay, now this tells me a couple things. One, it tells me that this is actually the amount of water I'll produce. You'll always produce the lowest amount, but also it tells me that this is my limiting reactant. Okay, so I killed sort of 2 birds with 1 stone. I know what the limiting reactant is. I know how much water I'll actually produce if I only have 100 grams of water or 100 grams of oxygen. So then the last step is how much energy, how much heat will I really produce on this problem. Always use the limiting reactant. So I'm going to start back at 100 grams of O2. And then this becomes incredibly redundant because you still have to get it to moles. But in this case, what I want to do is get it to kilojoules. Okay, so now according to this, for every 2 moles of O2, I will produce 78.87 kilojoules of energy. And so I will produce 123.2 kilojoules of energy for this reaction. Hopefully that helps. I'm going to go ahead and do the second one real quick as well to sort of set that up. So by the way, those are my answers for that. This one, I sort of set up a grid because we're after a bunch of stuff. In this problem, we're after grams of salt you'll produce, but you have to figure out the limiting reactant. And one way of figuring out whether you need a limiting reactant on this is that if you see, for instance, here, 50 grams of sodium and 10 liters of chlorine, I'm given two amounts like that, chances are you're going to need to find a limiting reactant. So what I'm going to do is I'm going to use that balance equation. I'm going to start with 50 grams of salt. Oops. You know what? On the problem, on your worksheet, it's going to be 20 liters. So 50 grams of sodium is 22.99 grams. 1 mole of sodium. And then it's a 2-to-2 ratio. What I'm after, by the way, is I am after salt, an HCl, grams of an HCl. So according to my balance equation, for every 2 sodiums, I need 2 NaCl's. So looking up the molar mass of NaCl, it's 58.44 grams, 1 mole of NaCl. And by the way, this is NaCl and this is Na. And in this case, I'll get 127.1 grams. Okay. Now if you use 20 liters, my oxygen, my chlorine. Now remember, this is STP, so that relationship is this. For every 1 mole of Cl2, you have 22.41 liters. That is something that you should know about. You should write it down. You should remember that. If it's not an STP, you'll have to use PV equals nRT to figure that out. But this is great. We have STP. I'm going to do the same ratio. So that's that first step, getting to moles of Cl2. From here, for every 1 mole of Cl2, I will get 2 moles of NaCl. And this last step will always be the same, is getting to the grams of NaCl. That way, you can compare the 2 gram amounts. And in this case, I'll get 104.3 grams of NaCl. Again, this tells us 2 things. One, that this is the amount of NaCl produced, and this is my limiting reactant. Now from that, you do the last step, which is, hey, how much energy you produced? You always use the limiting reactant. Start again. So you have 1 mole of Cl2, 22.41 liters. In this case, it is for every, let's see, for every 1 mole of Cl2, I'll get 411.0 kilojoules of energy. And we don't need this extra box, but the answer ends up being 733.6 kilojoules. Now, I didn't answer that in order, but I'll answer the last one right now, which is how much is in excess. So what I'm going to do is I'm going to go ahead and add another box here, line here. Not as pretty as the other ones, but I'm going to do the same thing. I'm going to start with my limiting reactant, always. And then in this case, same thing, very redundant. And then I want to know how much chlorine how much sodium I really need. So what I'm going to do is I'm going to go ahead and say for every 1 chlorine, I need 2 sodiums, and then get 2 grams of sodium this time. And what this tells me is I need 41.04 grams. Okay? What was given to me was 50. So if I subtract those two, what I'm going to have left is 8.96 grams of sodium that's in excess. Okay, that helps.